Hello and welcome to Season 3, Episode 20 of Logicast, the AWS News podcast brought to you by Logicata. I'm Carl Robinson, CEO and co-founder of Logicata, and I'm joined by my ever-faithful colleague today, John Goodall. How are you doing today, John?
I'm warm and uncomfortable.
It is getting a little bit warm in these sheds, isn't it, with the doors closed? But, you know, we do what we do for the cause, as they say. So
Suffer for the art.
Absolutely. And unfortunately, we don't have a guest joining us today. So you've just got the pleasure of mine and John's company. Our guest is in the air at the moment. And airplane Wi-Fi hasn't quite got to the point where we can manage to get a reliable live stream going to record a podcast. So we will get her booked in again for a future episode. Regular listeners to the podcast will know that every Friday I curate a list of AWS news that I share via my weekly AWS News Roundup newsletter. And then John and I pick a subset of the articles that we would like to talk to you about during the podcast. So we do, of course, have a selection of articles to talk to you about this week. And the first one is more of a feature announcement than an article. But John, I can see you've worn a T-shirt especially because it's about GitLab. So is it coincidence or did you deliberately dig that one out and iron it for the episode today?
I didn't iron it. I don't iron my T-shirts.
Oh, well, you know, you got away with it.
It's a trick. It's a trick I picked up back when I worked in London. Was so long as they didn't look offensively wrinkly, by the time you'd sat on a train for 20 minutes or sat at your desk for half an hour, no one's going to notice. So why bother?
I wish that worked with my face. Anyway, on that note, back to the article. It's a new feature. Amazon Elastic Container Registry adds pull-through cache support for GitLab.com. Sorry, John, have I thrown you completely? You might have to stay on mute
need
for
a minute
while I waffle. It looks much worse with the iPhone camera, I have to say. But yeah.
Every wrinkle and pore in 4K.
Absolutely. But back to the article. Amazon Elastic Container Registry has added pull-through cache support for GitLab.com. Why is this exciting? Why have you picked this one today, John?
Oh, because I had a GitLab T-shirt and I needed an excuse, obviously.
I wish I'd known. I would have worn the GitLab socks.
Don't put your feet on camera. That's an entirely different brand of media.
I think the GitLab socks are still hole free as well. So yeah,
not pulling anything through them.
Testament to the quality of their swag.
Apparently, this is cool. I like this outside of swag and borderline not safe for podcast jokes. I like this because what this is doing, this is blurring the lines even further between an AWS backed service and a third party service that you can use from within AWS. So historically on the podcast, we've sort of said, well, why the hell would you use code commit? Why the hell would you use code build or code pipeline or whatever? Because external services, GitLab and GitHub being the obvious ones, Bitbucket sometimes, are available better. They're not cheaper, but they're generally better. And they're just nicer to use. And the argument that we've always had has been, well, because it keeps your world entirely within AWS, simplifies your billing, makes the security team happier with you because they're not having to vet more and more tools because you've gone tool happy and decided, I want this, that, and the other. Cool. This is blurring the lines a little bit there. So ECR, for the uninitiated, is Elastic Container Repository. And it's where you store container images for consumption further down the line. Now, for certain things, you have to use ECR, right? So if you want to run an ECS cluster or an EKS cluster, I don't think you have to use ECR, but it makes your life a hell of a lot easier because it's there and the permissions are a lot easier to work with and so on. And then if you want to use container-backed lambdas, you have to use ECR. You must use ECR. There's no other way of doing it, as far as I'm aware. Cool. This is nice, though, because what this means is you can use your external service, your GitLab service in this case, to build your images in the way that you would for running in any other cloud provider or on-prem or on your machine or whatever. And then you can just point ECR at GitLab and your Kubernetes cluster or whatever talks to GitLab, talks to ECR to say, give me this image. ECR goes, I don't have this image, goes and gets it from GitLab. brilliant. Love that very much, because it means you're not having to worry about storing the image in lots of different places, and you don't have to build the image and then push it to ECR, because you've built it in GitLab, you've stored it in GitLab. That's a much simpler workflow. You're not having to worry about where to pull it from. So it's just everything's in one place, and then ECR is just pointing back to GitLab. And this is a fairly common design pattern if you look at older style artifact repositories, things like JFrog Artifactory or Nexus or those sorts of things, or like NuGet package repositories, where you can have your own internal package repository, which your internal clients can talk to. And this was more commonly used in enterprise, where default access to the internet wasn't allowed, particularly for your servers, because they were like internal. This is the enterprise, we don't trust the internet. But you could have like a mirror repository or a pull-through repository that did have access to the internet to then go out to the internet and get the packages. So this is a fairly common design pattern. And again, that kind of feeds in with this, where you could be running things where they don't have an internet gateway, but they don't need it because you're talking to ECR through an endpoint, and ECR is handling going out to the internet. So this is nice. I like this for specific workloads and use cases. Like, if you need this, but it's nice that it's available.
So I'm going to correct you slightly there, and then they're going to ask a very confusing question because I'm confused. You said ECR is Elastic Container Repository. It's actually Elastic Container Registry. But then the article goes on to talk about upstream registries and it goes on to talk about ECR registries and ECR repositories. So are they different, or are they the same thing?
Technically they're different, but the term is used interchangeably. So historically, a registry is where you kept container images, and a repository was where you kept binary packages like NuGet packages or apt-get packages or whatever. Technically, the term is used somewhat interchangeably now, though.
Because it says that here it can automatically sync images from the newly supported upstream registry to the private ECR repository. But then in the next sentence, it goes on to say customers can create a pull-through cache rule that maps an upstream registry to a namespace in their private ECR registry. So it's talking about the ECR repository and the ECR registry. So I'm wondering, is the author getting confused, or are they different things?
I might be wrong again. I think so. My understanding of registry versus repository is a registry is a collection of repositories.
Okay. I'm glad we've clarified that.
Clear as mud.
On that note, let's move on to the next article for this week then, after having confused ourselves completely about registries and repositories. And hopefully, maybe a listener will know and can clarify that for us. But let's move on to the second article for this week. And this is a charging announcement, effectively, that Amazon S3 will no longer charge for several HTTP error codes. And I think, I don't know if it was last week or a couple of weeks ago, we had an article about a developer who had managed to run up quite a large bill purely based on error codes. And this feels to me like it's potentially a reaction to that scenario.
It's exactly that.
Would you agree?
It's exactly that.
Yeah.
It's 100% that. So the original issue, and the issue has existed since the beginning of S3, but it kind of never really got any traction. No one ever really noticed or cared, was a developer had created an S3 bucket. That bucket had a name that was the default name for some, quote, open source software, quote, one of the most popular open source tools. No idea what, don't really care. And its backup configuration, the default, was that S3 bucket. Therefore, every single person that had malconfigured their backup for that tool were trying to access this bucket that this poor bloke had made. What that meant was that over the course of a couple of days, he ended up with a bill for a load of unauthorized requests for like $1,400 or something silly. And he then, bit of sort of security analyst type brain took over, made it publicly writable because, why wouldn't you? And in about half an hour, he collected 10 gigabytes of backups of this tool. He reached out to both AWS support, who graciously cancelled the bill, but it's, quote, this is the exception, not the rule. Fine, okay, that's the terms of service. And he reached out to the open source tool devs who also changed their defaults, I believe. But obviously that didn't affect any deployments that were already in the wild using the wrong default. So this is kind of then going on from there. What the change is, and Jeff Barr, the original, evangelist and all the rest of it, basically went, yeah, we'll fix it. And then about a week later, we went, yeah, we fixed it. And then this is the formal announcement. The change is pretty simple, and it's only in the billing, so you don't need to do anything as a customer to take advantage of this change, is access denied error codes, so 403 and a few others that originate from outside of your AWS organization will no longer be chargeable. That's it. That's the whole thing. This problem was highlighted to them. It's probably highlighted to them through support a number of times, but it was highlighted to them through public channels, and then it was fixed. You will still get charged for 403s and so on from within your organization and within your account. So if you've made a mistake and you're hitting your own bucket a lot and getting access denied, you're still going to pay for that. So don't think that this will go away, but it closes a denial of wallet attack vector. It closes the fact that someone historically could just spam requests to an S3 bucket and drive you out of business because you can't pay your bill. It closes that. So yeah, good. Why it took 17 years to find this is beyond me. But when it was publicly disclosed and it was kind of in the public zeitgeist, as it were, then they fixed it, and they fixed it within a couple of weeks. So bad that it took this long to find, and I suspect it was reported privately before, and there's probably not internal reporting channels for these problems, I suspect. But once it was, aware at the right levels, it was fixed. So
nice. That's what we like to see. There is a link to a full list of error codes which are no longer billable from external requests in the article. They are 301, 307, 400, 403, 404, 405, 409, 411, and 412. But if you want to read those for yourself, click the link in the show notes to the article, and you'll find a link to the page that I'm looking at with all of those error codes that are no longer billable.
409 is useful because that's a custom code that means you've been rate limited.
Yeah.
So that's good that they've made that one non-billable, because if you start getting a flood, then it will change from 404s to 409s. And yeah, okay. So it has been thought through properly.
Excellent. On that note, Len, let's move along to the next article for this week. And this is an article from the AWS security blog about how to use AWS managed applications with IAM Identity Center, enabling Amazon Q without migrating existing IAM federation flows. That's a hell of a title for an article. A lot of words just in the title alone. But what's going on here, John?
Sorry, I'm going to correct myself. It's not a rate limit. That's 429. 409 is a conflict.
Oh, sorry, I'd moved on.
We don't need to issue a correction after the podcast. Yeah. I've done it immediately. Fine. Right. So, is this the Amazon Q one?
Correct. Yeah.
Okay.
Managed applications with IAM Identity Center, enabling Amazon Q without migrating existing IAM federation flows.
Yeah. Okay. So, Amazon Q. This is kind of the darling of the world at the minute. This is you can do all sorts of things with Amazon Q. It hooks into this, that, and the other. Fine. If you needed access to Amazon Q, you needed access to the console. Unless you'd built like custom workflows and exposed it through APIs and all that kind of thing. If you needed access to Amazon Q just as is, you had to have access to the console. What this is doing is it's showing you how you can enable access to Amazon Q through AWS just as it is, without kind of building on top of it, without giving someone full console access. It's not the only service that supports this. A number of them do. So Client VPN is the one that I'm aware of, but there's a few others where you can hook into IAM Identity Center, say you have access to this application and only this application, off you pop. Brilliant. I like that. I do, because it means you don't have to give out people access right into the inner workings of your account structure just to get access to this kind of LLM chatbot that you may or may not be using. Cool. Doesn't, however, solve the problem that Amazon Q is still horrifically expensive.
Well, there are a couple of different subscriptions that one can subscribe to, one of which is a factor of 10 lower than the main sort of enterprise level subscription. But yeah, I guess it depends on the use case and what value you're going to extract from it as to whether or not it is perceived as hideously expensive or not.
Yeah, it's an interesting one because the people that I would want to give access to Amazon Q in one form or another without giving them main access to my whole console would be people like salespeople and what have you. So they can ask business questions based on your business domain because you can tell Q about those things. And the business light, I think, was $3, which is fine. That's not horrific. Business full was 20, I think. And then the developer version, which is what the example that the article uses here is, you can give access to Amazon Q and then you can speak to it in your IDE without having to have access to AWS. Your developers should have access to AWS if they're writing things for AWS anyway, shouldn't they? Maybe that's my small company brain, and enterprise John would go, yes, this is a very good idea because I don't want them getting anywhere near any of my kit. But I thought the whole purpose of the cloud was democratizing access to these sorts of things. So the use case, I'm struggling a bit. It's cool that you can do it, and like I say, it's not the only application that you can do it with. Client VPN being an excellent one for it, because you could just be running VPNs and then exfilling out of somewhere or giving access to web portals or whatever, so you really don't need access to the console for that. So that's a great example where you would be using it, but I'm struggling on this use case. I really am.
Yeah, well, if you're struggling, there's not much I'm going to be able to shed any light on there in this article. But if listeners do have a use case, then the article does give a great step-by-step walkthrough of how to actually set this up and configure it. But it's going to be interesting to see how these use cases pan out, because a lot of this is all very new, and we're not exactly sure how people are going to use these things in their day-to-day working lives yet. On that note, let's skip on to the next article for this week, which is from the Container blog. I'm not sure we've had an article from the Container blog before. Certainly haven't had one recently. Anyway, this one is about multi-region disaster recovery with Amazon EKS and Amazon EFS for stateful workloads. So EKS, obviously Elastic Kubernetes service, and EFS, the Elastic File Share, Amazon's managed service for NFS file shares. So this is all about multi-region disaster recovery. So again, probably very enterprise workload focused here, I would suggest, if it's Kubernetes and it's multi-region failover. But what caught your eye about this particular article, John?
All of the TLAs. I thought you'd like to define them.
Oh, yes. Well, we've got some more AZ, availability zone, and VPC, and we've got PVC as well, persistent volume claims. That's a new one on me.
That's a Kubernetes thing. So this is interesting. I picked it before I'd kind of read it and then thought, well, we'll dig into it a little bit. So, right, what's going on here? Let's just talk through this diagram for a minute. For your sins, you're being forced to run something in Kubernetes because you must have committed something terrible in a past life to have to run workloads on Kubernetes. Right, next. Those workloads then are stateful, which again, you're running something in something that's designed to work as much as possible statelessly. So again, you must have committed some sort of atrocity to have to work with this sort of workload. But okay, fine. So what you've done the sensible thing, and you're using EKS, so you're not managing about 80% of Kubernetes. Cool, we like that. And then you're mounting anything that needs persistent volumes onto EFS. Sensible, very sensible thing to do, because you don't have to worry about backing it up. You don't have to worry about how all of your various EC2s or FileGate tasks can get to it. It's just kind of there. Great. We like that very much. You're then tasked with, so if we lose an entire region, how are we going to cope with that? And the answer of, well, we're not, because who gives a toss, isn't an acceptable answer. That's historically been my answer, is if we lose a whole AWS region, we have bigger problems. But I don't know, maybe you've got a regulatory requirement or a paranoid CISO or CTO or something like that. So what are you doing? Well, you've got a whole hot setup by the looks of this diagram, and you're replicating the file system. That's really cool. That's actually really cool because you're not having to worry about vast amounts of things going on. The file system under the covers is just handling it. It's just handling it, which means you've got this really nice hot setup. And if the world goes bang, if your entire region is taken out by, I don't know, thermonuclear attack, meteor strike, Godzilla, other non-Japanese monsters, those sorts of things. Maybe you've been playing Sim City and you just put a robot in your data center. I don't know. Maybe the whole thing's been killed and your hot DR is already ready to go. So assuming that you've used something sensible and you've got automatic DNS failover as well, then it's just gone, oh, it's dead. Oh, I'm over here. And you're still rolling. That's really cool. That's the stuff that 10, 20 years ago, engineers would be having sleepless nights over how to get that to work. You're talking microsecond failover on a really cool architecture, but you are still having to run Kubernetes. So you have my undying sympathy, because how would you do this with something like Lambda? Well, again, you do the same thing. You replicate EFS because you can map Lambdas to EFS, but they've decided to do this with Kubernetes for some reason.
What about the data that's not stored in EFS?
Well, then the assumption, that's the assumption, is that it's not part of the stateful data set. So the big upshot of containers historically, and then serverless more so, because there's a big overlap, is the point with a container is you give it a request, it processes the request, and then it's done. Yeah. Originally, they weren't even meant to be running consistently. Much more of the serverless view of, well, we'll bring them up when they're needed, they'll serve the request, and then they'll get rid of them afterwards. But that's really hard to do. So what you find is containers just sitting there running, waiting for a request, working like a very, very scaled down VM. But what they do is they process the thing and then they get the thing back out the door again. If they've stored anything locally that's not on a stateful data set, data storage medium, EFS, or backed onto EBS, or out to a database or something of that nature, the idea is that you didn't need to keep it.
Fair enough. And of course, like the previous article, this article is very detailed, and I think it goes on to explain how to implement this solution if it's something that you are interested in trying out for yourself. Although based on John's opinions, it sounds like perhaps you better not.
I'm really convinced you must have done something really horrible in a previous existence, if you believe such things, to have to run workloads that are both Kubernetes based and stateful. There's better ways of doing it. There must be better ways of doing it beyond the whole, well, we've got this in a server and we want to go into containers. Okay, but we still need to keep all of this data hanging around between executions. Okay. Like this smacks a little bit of, we're going to containerize every workload just because we can. It reminds me a lot of running, say, like a database in containers. Yes, you can actually run, say, a Postgres service out of containers in Kubernetes, but you do need to have stateful data storage somewhere else. It needs to be on a disk somewhere. So you're mounting your container to a disk and you're keeping the data forever. I'm sorry, but a container just wasn't originally meant for that. It can be press ganged into service, but I don't see that there's any advantage to doing that over just running it on a appropriately specified server. I'm a serverless guy. I like serverless. So my default is manage services and let Amazon run it better because they can run it better than I can. But I don't get it. I fundamentally don't get it.
Simplified management, perhaps.
Not really.
If you're doing everything in Kubernetes, just a few more containers within the same platform, maybe. Yeah,
but then you're still going to have the same. We still need a DBA to be able to look after this damn thing, even if it's running in a container. So I don't get it. I don't think I ever will until someone that's doing it comes up to me and says, "Oi, here's why we're doing it," and then it might make sense. But I've never found a workload that I've agreed with that design pattern.
You know what we need? We need an AWS. We need an AWS container hero or an AWS container community builder to come on the podcast and explain this to us. So if you're a container hero and you're listening, or you are a community builder here, a community builder in the containers category, and you are listening, then come and join us and explain this. to
I
me
like
and John
containerized
and to
workloads.
all of
I
our listeners.
do. I really like containers. I don't like things doing stateful stuff that isn't just a server, because that's like, what's the point?
Well, on that question, which we don't have the answer to, let's skip on to the final article for this week, which arguably is the biggest news to come out of AWS for the last few years. There is
Since the
another
last time it
change.
happened.
Yes, about 3 years ago. There is a change at the very top. There was an announcement, or several announcements last week, that Mr. Adam Silipsky is stepping down as CEO of AWS. And Matt Garman, AWS lifer, as I referred to him in the newsletter, is stepping up to the role of CEO. So going to be very interesting to see how this changes things. And read a few of Corey Quinn's reports on this already. His email today saying that he's more excited than he's ever been to attend reInvent this year since the pandemic. And hopefully you and I will also be attending. It would be Mr. Garman's first keynote at AWS reInvent. So what do you think he's going to have for us, John? What do you think is going to change apart from the name of the CEO?
I don't know. They're both. I mean, Matt's not wearing a suit jacket, and Adam is in those pictures, so maybe they'll be a bit less formal. Maybe. I don't know. I don't know enough about the pair of them to kind of compare and contrast. But, and I'm not quite quoting verbatim, but the whole Adam Silipsky is going to be the new AWS CEO. Who? Who? Because he'd been at AWS on and off for 15 years or so, but he'd kind of been in and out and in and out.
Been at Tableau, I think it was before, wasn't it? Before he came back to AWS. So.
Which is, I don't know. I don't fully understand Amazon generally's internal hiring and promotion practices, but my understanding was they were big fans of promoting internally, and then they'd gone out. What looks like either they'd kept a relationship with the guy, fair enough, or they'd gone out to the market, found a guy that they sort of knew, and brought him back in. Because when Jeff Bezos stepped down from Amazon proper, was the AWS CEO that kind of went up that way. So it was, okay, that makes sense. And then this one was, what the hell's going on here? This is more of, I feel, a return to form, where they've got a guy, they know the guy, he's been there forever and a day, we're going to bring him up. So that feels more like a return to form.
And I think a lot of the analysts expected that Matt was going to be announced as CEO previously when Adam actually stepped into that role. As I mentioned, he is a lifer, so he's been there for, I think, how many years? 18 years or something like that?
Something like that.
And one of the articles I read said that potentially he's going to bring back more focus to the bread and butter, meat and potatoes, whatever you want to call it, traditional services, rather than all of the kind of AI fluff. In fact, I read another article where he was actually quoted as saying he needs to brush up on his AI because that's not where he's been spending most of his time. So it'd be interesting to see, certainly from a reInvent agenda perspective, how heavily AI features versus core services.
Yeah, I mean, AI is something, it's not quite vaporware, because we are seeing genuine use cases and workflows and workloads using it. I mean, we've got one, which is albeit a bit sort of fluffy pumpy, like, it's whatever. But, we've got a workload that uses AI. We're seeing actual use cases for AI. But the last time I saw it was 60-something% of AWS's revenue came from EC2. So traditional, what I like to call meat and potatoes workloads, and that's a very British turn of phrase, but the short version is a very traditional English dish, is a meat and 2 vegetables and potatoes. Okay, meat, potatoes, buff. A very meat and potato sort of workload is coming on EC2, and EC2 is where they're getting loads of money, loads and loads of money. AI and, kind of by extension, things like serverless and containers and what have you, aren't really making any money because of all of the reasons that we like them. They scale to zero, they're easy to use, they're flexible, blah, blah, blah. But most of the revenue is coming from the meat and potatoes. It's coming from, and we see this from our customers as well, it's coming from EC2 and it's coming from RDS. That's where 70+% of most people's spend is going to be. And then there's some logging and stuff around that as well. But the fact that he might need to brush up on his AI doesn't bother me particularly, because whilst AI is cool and we like AI because we've kind of gotten off of the bandwagon of hating it, so we like it now, a return to we are the cloud infrastructure people rather than we are this hybrid, we do some infrastructure, we do some of this, we do some of that. No, what you're good at is top quality infrastructure. Do more of that, please. So maybe we'll see some of that.
Yeah, and I think with the quoted 85% of workloads still not being in the cloud, there's still plenty more of opportunities for migrations into those traditional cloud services. Yes, we're all for modernization, but not everyone's in a position to modernize. Doesn't mean they're not in a position to migrate and take advantage of some of those core services. So, yeah, let's see. Let's see what this change is going to bring moving forwards. But what it has brought is us to the end of our time for season 3, episode 20 of Logicast. So thank you, John. Despite the technical problems in our preamble, we have managed to get through the episode without your connection breaking up.
It's definitely your fault.
It could well be. Yeah, I am the gremlin in the system normally, or at least most of the gremlins seem to be in my personal system. Computer, that is, not anything else. On that note, we have reached the end of season 3, episode 20 of Logicast. So thank you for listening. If you've made it this far, if you enjoyed it, tell your friends. We are available to download wherever you get your podcasts. And if you'd like to see the odd faces that John and I pull from time to time, then we are also available to stream on YouTube. We'll be back next week with another episode for you. No, we won't. We're both off next week. We'll be back in a couple of weeks with another episode for you. And we'll see you again next time. Thanks for listening.